Question number 1. What is backfilling? Filling of selected soil layer by layer with the compaction to achieve the required level to create a floor area or surface area. It means that the soil will be selected based upon the characteristics defined in the project specification, and then it will be laid layer by layer to create a floor area or surface area. For example, in the building we do the backfilling up to the ground floor level and we create a floor area, and in the road we do the backfilling up to the bottom of the road structure and we create a surface area. Next. Question number 2. What are the parameters for selecting the backfill material? Number 1 is the gradation of the backfill material. Gradation of the backfill material is nothing but the sieve analysis, and it will tell us what is the minimum size and what is the maximum size of the material used for the backfilling. California bearing ratio is CBR value. California bearing ratio determines the hardness of the material and it should lie within the specified range. Atterberg limits are liquid limit, plastic limit and plasticity index. Swelling is also not desired and it should lie within the specified range. Acid, soluble sulfates and chloride content. These sulfates and chlorides are not desired in the backfill material because they will react with the concrete and they will cause the corrosion to the rebar. Similarly, organic matter will be present there, but it should be present in traces. Next. Question number 3. What tests are performed on the backfill material? Number 1 is the gradation test. Gradation test is nothing but the sieve analysis, and the sieve analysis is done for the backfill material, and a curve is drawn between the particle size on x-axis and percent passing on y-axis. So it determines whether our selected backfill material is lying within the specified range of the particle size or not. Number 2 is the Proctor test. Proctor test is performed on the backfill material in the laboratory to determine the maximum dry density and optimum moisture content. FDT test to determine the relative compaction. FDT test is performed on site on the compacted soil to find the in situ dry density. Moisture content test. Moisture content test is performed in the laboratory to find the optimum moisture content, and at the site also it is performed, and the site moisture content is compared with the OMC. CBR is California bearing ratio test, Atterberg limits determination, chloride and sulphates content determination, and organic matter determination. So these are some of the tests for the backfill material. Next. Question number 4. What is frequency for testing of backfill material? FTT test at every layer thickness 200 mm loose. Means that FTT test will be performed on each layer. Moisture content at various intervals at backfilling. Gradation test after every 1000 cubic meter delivered to the site. In the QC department, you are receiving the delivery notes for the material received at site. So once you come to know that the material received is exceeding 1000 cubic meter, so you will inform the consultant and the third party, and you will arrange the sampling for the backfill material. So for the gradation, the sampling will be done after every 1000 cubic meter delivered to the site. Similarly, for the Proctor, after every 3000 cubic meter. For the CBR test, after every 1000 cubic meter. For Atterberg limits, after every 1000. Chloride and sulfates after every 3000, and organic matter after every 3000. So this is the frequency for the testing of the backfill material. This is very important. It means that the material is being received at site. So after a specified quantity being received at site, you will perform this testing. Next. Question number 5. What are the characteristics of the backfill material? Number 1 is the gradation of the backfill material. The minimum size is 0.075 mm and the maximum size is 75 mm. So our material should lie within this range. CBR value should be 20 to 30%. Atterberg limits, liquid limit 30% maximum and plasticity index 10% maximum. Liquid limit is not desired more than 30% because it will cause the consolidation settlement. Swelling is the change in volume and it is also not desired, it's 2% maximum. Acid and chloride content 2% maximum. They are also not desired because they react with the substructure and they cause the corrosion to the rebar. Similarly, organic matter 3% maximum. Relative compaction 95% of MDD. So for finding the relative compaction, what we do, we compare the in situ dry density with MDD. We divide the value of maximum dry density at site by the maximum dry density in the laboratory and we multiply with 100. and the value should not be less than 95%. Similarly, the moisture content should be plus minus 3% of optimum moisture content. Next. Question number 6. What is MDD and OMC? MDD is maximum dry density for the selected backfill material, which is determined in the laboratory by the Proctor method, and OMC is the optimum moisture content. So what we do once we receive the backfill material at site, we do the sampling by the third party, and the Proctor test is performed in the laboratory to find the MDD and OMC. A graph is drawn between the moisture content and the dry density, and the moisture content at which the maximum dry density occurs is called the optimum moisture content. So MDD and OMC values are very important, because when we perform the field density test, so then we compare the values of the density, in situ density, and the optimum moisture content at site to the values of MDD and OMC. So that's why this is very important. Next. Question number 7. Why FDT is performed, and describe the test apparatus. FDT is performed to find the relative compaction. Field density is determined using nuclear gauge or sand cone apparatus, and then divided by the lab density determined by the Proctor to determine the relative compaction. So relative compaction is equal to density in the field divided by MDD into 100. So in our home countries like Pakistan, India and Bangladesh, we still use the sand cone apparatus, but here in Gulf countries we use the nuclear density gauge. So what we do, we find the density in the field, and then we divide by MDD, which is the value of maximum dry density in the laboratory, and we multiply with the 100, and the answer should not come less than 95%. For example, in the field the value comes 1.78 gram per cubic centimeter, and the value of MDD in the laboratory is 1.85. So what we will do, we will divide 1.78 by 1.85, and we will multiply with the 100, and the answer should not less than 95%. If it is less than 95%, we cannot move forward, and we'll have to do the compactive effort to achieve 95% of maximum dry density. Next. Question number 8. What is CBR test and why it is performed? California bearing ratio is used to determine the relative hardness of the material against the standard material. The penetration of standard plunger into the material at MDD is noted and divided by the penetration of the same plunger into the standard material. It should be 20 to 30% for the backfill material. So for finding the California bearing ratio, what we do, first we compact the sample up to 95% of maximum dry density, and then we note the penetration of the standard plunger with a standard load in the standard time. So this is very important, and it is essential for the road structure and also for the building. Next. Question number 9. How gradation test is performed? It is sieve analysis to determine the percent passing through standard sieves of different sizes. So a curve is drawn between the particle size on x-axis and the percent passing on y-axis. So this curve which is drawn for the selected backfill material should lie within the upper bound curve and the lower bound curve. The upper bound curve is drawn keeping in view the maximum sizes for the selected backfill material, and the lower bound curve is drawn keeping in view the minimum sizes. So this selected backfill material should lie within the specified range. There is also a video in the description link where you can see how a curve is drawn for the selected backfill material. Next. Question number 10. What is method of backfilling? First of all, we will get the clearance of all mechanical, electrical and plumbing and structural members. Means if there is some structural work there, so we'll get the clearance, and then we will get the clearance from the waterproofing division, and then the bottom of the backfill is properly compacted. Means that if there is some loose material there, if there is some waste there, we will remove that waste and loose material, and we will compact the bottom of the backfill. All the formwork is removed and the area at the formation level is made clear. First layer of 200 mm loose thickness properly compacted and tested. Means that after all the area is clear, we will make the ramps and we will move the machinery inside and we will lay the soil, and the first layer will be 200 mm loose and it will be properly compacted and tested, and after the FTT is clear, we will move to the successive layers, and the relative compaction must be 95%. It should not be less than 95%, and moisture content should not be less than 3% or more than 3% of the OMC. Next. Question number 11. What is method of backfilling for trenches? First of all, we get the clearance of all utility lines and services. So trenches are basically the excavations for the phone cabling and optical fiber. So first of all, we will get the clearance of all the surfaces and utility lines, whether they have been laid or not. And then we will lay the first layer, which will be 300 mm loose, and we will compact it by hand to avoid any damage. And then all the successive layers above that will be 250 mm, and they will be compacted and tested by FTT. And another thing we will do here, when we are approaching the ground level, so 600 mm below the ground level, we'll put the warning tape, so that if in the future if there is some excavation, so that the people working at site, they come to know that there are some services below this. So this is the method for the backfilling of trenches. Next. Question number 12. What is method for the backfilling of pipes? So if pipes are coming in the road cross, then the pipes will be surrounded by the concrete, and then they will be backfilled layer by layer with the soil, and every layer will be tested. Means that what we will do, we will first do the PCCR blinding, and then we'll lay the pipe, then we will again do this blinding, and then the above area will be backfilled with the soil layer by layer. And for the areas other than road, if depth is less than 1 meter, so if the pipes are not coming in the road and they are coming in the park or where the road is not there, but the depth of the pipe is less than 1 meter, so then again the same process will be repeated. Means that we'll do the blinding, we'll lay the pipe, again blinding, and then the above layers will be laid one by one, and every layer will be compacted. And if the depth is more than 1 meter for the areas other than road, then what we will do, we will first put the natural gravel, because if the crushed gravel stone crush is laid there, so it will damage the pipe. So the natural gravel will be laid, and then the pipe will be laid. Again the natural gravel will be put above the pipe, and then we will put the geotextile and then dune sand, and the above area will be backfilled with the soil layer by layer. So this is the method for the backfilling of pipes. This is very important. Next. Question number 13. Why compaction is done, and what are tools and machines used for compaction? So compaction is done to remove air voids and to densify the soil to avoid settlement and slope failure. So the main purpose of compaction is to avoid the soil causing the settlement or slope failure. When we apply the compactive effort, so the air voids are removed and the soil particles get closer, and there are no chances for the settlement or slope failure in the future. Tools and machines are used for the compaction are hand tamper, vibrating plates, rollers, which can be plain and sheepwood depending upon the type of soil, and vibro compaction rollers. Next. Why water is added during the compaction, and what should be the pH value of the water? Water actually acts as a lubricant, and the air is removed easily during the compaction and particles are packed. Means that when we apply the compactive effort, so the soil particles, they come close, and if the water will be there, it will act as a lubricant, and these soil particles will slide and will be packed. pH of the water will be 6 to 8, means that the water used will be potable water. Next. Question number 15. How a slope area is backfilled? So benches and ramps are made of the proper width for the movement of machinery. So what we do, first of all, we make the benches and we also make the ramps, so that the machinery can move easily. So all those ramps at different levels will be backfilled similarly as the normal backfilling, layer by layer, and every layer will be tested. Next. Question number 16. Can we use excavated material or recycled material for the backfill? Yes, if it meets the requirements described in the specification and up to the satisfaction of engineer in charge, which is supervision consultant representative. Means that the engineer from the consultant, if he is satisfied and he says that okay, this material is lying within the range, then you can use the excavated material or recycled material. Next. So guys, this is all for today's video. In the next video, we will make the interview questions about the painting, how we do the process of painting. So you all are requested to like, share, comment and subscribe, because this gives us extra energy. So until the next video, Allah Hafiz.